go ahead and kick us off here. So hello, everybody. This is the Dynamic Soils Property presentation. Myself, Cody, and Elliot will be giving it here today.
All right, so yeah, we are the Dynamic Soil Properties Group. The company we worked with was the USDA, as I'm sure a lot of you are familiar with. And the products that we will be delivering is a graphical system with a map-based component. So essentially you can use the map and query for certain characteristics of soil that you want to find. And we have an API that we use to interface this system with a machine learning subsystem, which is a big database that was developed by another group that we essentially ported all the information from onto our webpage here. So our sponsor stakeholders that were involved with this was Candace Williams from the USDA. She was an absolute wonderful person to work with. She helped us so much. She provided project specifications and requirements, but she did a lot more than that. She was always there to email when we needed her and gave us a lot of help on guiding us in the right direction. And then from UNL, we also had Stephen Scott, who helped us a lot with understanding the what the other group did with the machine learning, as he has a lot of experience in that field. As for the development team, we had Melanie Kugler-White, who was our project manager, and Vinod Variam. Those two helped us a lot. After every week on Tuesdays, they would talk to us, tell us what we could do better, what we've been doing great. As for the actual team, we've got Jacob Atkins as our squad lead and development manager, Jonathan Trost as our product manager, Cody Berglund and myself, Xinyu Liu, Mike Schaefer, and Dimitri Segoa as developers.
All right, so I'm going to start talking about the general problem of this project and then go into a bit more detail on what our solution is. So our problem statement is since the USDA has a website with a lot of information about soil called the Web Soil Survey. However, that there is no such national website for these soil properties that changes with different things, including climate change, as well as that website being a bit out of date. And this kind of soil data is very important to policymakers and other people who use this land very often, especially when conservation is important. So, and as well, this information is used to train farmers and other people trying to conserve resources. And this will help immensely in that. So part of our solution is to create an easy to use web application such that any non-technical user can go through and find research-based articles about soil properties. And so users can pick their criteria for articles and base it out of certain regions and other parameters. And then this website will query our database and return the matching articles. So this is what the landing page of our app looks like, and it's a single web page app, and its main focus is searching by keywords and or these SEEP regions that you can see in the United States. And this map right here is a simple interactive one that you can simply click on these regions, and then it will populate the article area with the articles corresponding to those areas. So in this keyword section, we can use it to search for various keywords, either in specific dropdowns or at the very top, there is a general keyword searching, which will autocomplete. And then our dropdowns are more generally split by categories. So as you can see, there's one for heavy metals, there's one for crops, there's physical indicators, biological indicators, so on and so forth. And one at the top contains all of the currently selected keywords for an easy place to manage them all. And so again, like I was saying with the map, our states can be searched with on the map as well. So if you click on a certain region, it can highlight it. And we can also highlight multiple regions. And then there's also a simple map toolbar that can, it can clear the selected regions. If you move the map around or zoom it, you can reset it back to its default state, and so on and so forth. And then I'll turn it over to Jacob to discuss the rest of our project.
So obviously, as this is compilation of all the research articles and whatnot, we need to be able to see those. So down below the map, you have a results list. It splits out into pages that the query returns and splits out into pages to increase responsiveness. So if you pick a keyword like corn that might have tens of thousands of responses, instead of waiting a minute for that result, you can wait for a couple seconds to get 10, 25, or 50. And then to view them, you can hit previous or next page just to see more or less. And this also has various visual cues to tell the user if there's no articles available, or if it's still trying to load, there will be a spinner that shows up and overlays over top. For our backend was built using a lightweight RESTful API. This calls on the page load, and it initially calls on the page load to get an up-to-date list of the keywords for the search bar. So that's not hard-coded into our project. That's dynamically created. So if later on down the line, maybe they add another 100 keywords, this would just automatically grab those and, again, be always up to date. And then this API also contains different calls for the different search options we have. So one of them just does those keywords either through the drop downs or the search box. One is specifically just if they select a SEEP region on the map, or there is a SEEP region drop down that they can grab from as well. And then the final option is if they do both, basically. And then this data is, again, queried from our database and is returned in a really easy to process format. Basically just contains article title, authors, date, and critical information like that we can turn around and give to the users. And again, database is a very simple format based on previous designs for easy updating. So it's based on some formats that are easy for our sponsors or anyone else who is working on the data to manipulate and look at before it's turned around and been put it into the database. So you don't necessarily have to have direct access to the database to change or look at the data beforehand. So the value and highlights, this makes it very easy to access the USDA's database of articles. Currently, you would have to have a hard copy locally of this entire database, which is currently over 50,000 articles, and it's only going to grow over time. So this makes it much easier for the user to look for it. It makes it simple for the user to find specific articles for those keywords. Again, instead of having to generate your own query and understanding stuff like SQL commands, you can just have a visual interface that you can just hit what keywords you want. That provides a wide range of criteria as well as a selectable map. Again, this goes back to it makes it easier for you to find an article or kind of visualize where things are at. And finally, it enables policymakers to help make better informed decisions about land use. So for a demo, if you'd like to see this in action, you're welcome to visit our virtual table. The link to our meeting is available on the Senior Design Home webpage. And just as a final, just thank you again to our sponsors, Candace and Scott, Dr. Scott. You both have been very instrumental in us, both learning and actually being able to implement this over the year. And we could not have done it without your guys' help.
All right, awesome. Thank you to our presenters. If we could give them a virtual round of applause, either through the chat or the clap emote, that would be great.